Hey, everybody. Welcome to the IPMX Deep Dive session. My name is Jed Deame. I'm CEO of NextEra Video. We're IP providers for IPMX technology. If anybody wants even a deeper dive than you're going to get today in your seats, there's a little card. There's a training session tomorrow, no charge. You can register or just show up all day tomorrow training on IPMX. Okay, so, what is IPMX? If you missed Sam's presentation earlier, the way I kind of describe it is it's 2110 tailored for Pro AV. So instead of looking at gateways that go SDI to 2110, we're more in the HDMI or display port space, moving that to IP. We've done a couple things to make it easy, relax the timing. PTP is not required. It'll be used if it is in the system, but you don't have to have it. Can support compressed or uncompressed video, and also support for the Pro AV features that you see commonly like HTTP encryption. We also do custom encryption called PEP, and then we can support dynamic connections, meaning you can change the resolution of your sender in the middle of a transfer and the receiver will adapt to that. Where can IPMX be used? Well, I took a picture of our Infocom booth last year here in Vegas, and the guys did a really good job of setting up a lot of examples. So it's like a PTZ camera at the top. It's a good application for it. Down on the side here, there's an airport information screen where you've got a mixture of flight displays, text updates, advertising on the side. In a pub, you might have a multi-viewer application that could have a variety of things like menus and sports. Smart display modules, little boards that plug in the bottom displays to do IP right into a TV, and video wall applications on the side. Okay, let's talk a little bit about the AV over IP landscape. What we've seen is an increasing a demand for quality and interoperability in the Pro AV space. Obviously, there are a lot of other video over IP solutions out there, but not so interoperable. They're vendor specific. Demands for scalability, higher resolutions, higher frame rate, and some definite confusion over the available solutions that are out there today. And why do we even want AV over IP? Kind of obvious here, but extended reach, lower the infrastructure cost, provide some flexibility and scalability using COTS IT hardware. So some of the current solutions, previous solutions, I guess, that are available today, you've probably seen some of these. There's a technology from Semtech that's called SDVOE. There's some technology from BizRT called NDI, and some Autonate stuff for Dante. These all work well in their specific applications and their roles. They have their places, but they have some limitations and challenges that we're trying to overcome. For instance, there's not just one NDI. There's HX2, HX3, high bandwidth, and they're not interoperable, and didn't really do a good job of branding it. So you can't necessarily just plug one NDI device into the next. Similarly with Dante, you got AVA, AVH, Ultra, all built for kind of different niches and don't play with each other. So we're trying to solve these problems with IPMX by having a very clear badging program, branding program. So if it says IPMX compressed or IPMX uncompressed, it'll be very clear what works with another. So we're trying to get past this user confusion, make it easy for customers to adopt video over IP systems. So kind of looking at from the foundation, what should a next generation video over IP solution look like to get past some of these issues? We want to be interoperable. You want to be able to buy products from multiple vendors and just plug them together and have them work. We want scalable, be able to build large systems, industry validated codecs, not technology that came out of an individual vendor that might disappear if the company gets acquired or disappears, and standards-based. That's a key part. If it's standards-based, it's open, people can develop their own systems, and they'll live on beyond the life of a particular vendor. So Ames, who is sponsoring a lot of these activities, got a nice booth across the hall you should check out if you haven't. Developed this IPMX, Internet Protocol Media Experience, which is a set of open standards that defines how to implement this new approach to open AV over IP. So I'll dig into a little bit more detail on some of the other solutions that are out there and the pros and cons. Like I say, they all have their spaces where they fit. We're trying with IPMX to be more of a superset, kind of a foundation that works with a variety of different codecs and a variety of different bit rates. So SDVOE is a 10 gig only system, which is one of its limitations. It has the advantage of it's an ASIC, so it can get into some smaller footprints like wall plates, things like that. It's visually lossless, but again, it's running at 10 gig. NDI has some advantages where it can be run on CPUs. The SpeedQ codec is pretty efficient. You can run it in software. But there's no synchronization system. There's no standard control protocol that works across vendors. Dante's uses more advanced codecs, which is great. It's a proprietary version of J2K called Calibri, can handle higher resolutions, but again is proprietary vendor specific. So in IPMX, again, we tried to address these limitations and how do we build this one ecosystem that can support all these different codecs and application spaces. So Ethernet interfaces, it's not fixed. It can be anything you like, 1 gig, 10 gig, 100 gig, doesn't really matter. It's just a transport for that data. Codecs, the current approved codecs are uncompressed, JPEG XS, H.264, and H.265, which is HEVC. And the products will be labeled very clearly to tell you which ones are running which codecs, so you know what can be plugged in together. Since it's built on top of 2110, it has the super high resolution support, 32K by 32K. In the case of uncompressed, it's just a few pixels latency or up to a line. In the case of JPEG XS, it's a handful of lines, 16, something like that. It could also be run in software, CPUs or GPUs. There's some implementations out there that do that. And it's an open standard for control. That's kind of the key. How can we build a system that uses the already existing NMOS infrastructure that's so successful in the broadcast market? How can we extend that into the Pro AV market? Well, we built NMOS as a requirement of IPMX. PTP is optional. Use it if it's there. You don't have to use it if you don't want to. And, the quality is obviously, we're going after visually lossless quality, 4K P60 over 1 gig, and it does a great job of that. Okay, so I mentioned open standards a couple times. Why is that important? Well, you want to leverage the knowledge of an entire industry. The people that worked on these specs are the best and the brightest of all the major organizations, anybody that wants to contribute. So we're really draining their brains to have a solution that's going to work for a lot of applications. And they've got experience running in a lot of different ways. Reduce operational expenses by having a simple interoperable system. You don't have to worry about understanding all these different ecosystems. The IT team can just put one together and make it work. Multi-vendor plug and play. That's what the end users are begging for, especially the problems they ran into in COVID times when they had supply constraints. They built a system of 100 of vendor A. And they needed 20 more. They couldn't get it. Well, guess what? They had to buy 120 of vendor B's product and throw away the other ones. We want to get past that. Get rid of any intellectual property dead ends and enable media companies to benefit from the economies of scale of these large open markets. So some of the key technologies I kind of hinted before, it's based on 2110. You should actually think of it as a layer that sits on top of 2110, builds upon all the success that we've had in the broadcast market and adds in these extra layers to handle the needs of the Pro AV market. Uses the NMOS control, which gives us a plug-and-play switching capability, and optional codecs that are all industry validated, not custom proprietary codecs. So things like 264, 265, JPEG XS. So some key differences between 2110 and IPMX. How did we incorporate these capabilities for these extra Pro AV features? Well, first, we wanted to be able to handle sources that could change resolution, like a laptop. You're a presenter at a stage like this. Somebody plugs in their laptop, it changes the resolution. You don't want to have to reroute everything. in 2110, it was kind of fixed resolution. You assumed it wasn't going to change, and you rerouted it if it did change. Well, so to get past that problem, we added this thing called RTCP sender reports. It's an additional stream that's sent from the sender to the receiver that has the information once a frame about here's the video rate that I'm sending, the pixels, the lines, the frame rate, here's the audio information. So that's sent dynamically so that the receiver can automatically adapt to the sender. We improved the compressed media support, adding in handles and NMOS so that it knows what codec is being used on each end, so the control system can know and tell you source A is compatible with destination B. Support for HTTP and PEP, which is the other private encryption protocol, so that you can either do custom encryption for highly secure applications or work with HTTP encrypted devices, laptops, DVD players, etc. Added the other HTTP info frame support. You give you HDR things, and then USB, another important feature added to do things like KVMs. This is a list of the standards. You say, you said this is an open spec. Where it's an industry standard. Well, if you go to vsf.tv, you can download all these specs. Most of them are in final. The core set are finalized. There's products on the market. People are using them. There's a few more that we're continuing to work on to add features to. Timing and synchronization. As you know, in 2110, everything is locked to PTP. Everything's synchronized. You need to have a nice big grandmaster in your system. Those can be a little bit expensive, difficult to set up. We didn't want to have that burden on a Pro AV installation, so we made it optional. But again, the system will use it if it's there. Link offset delay, that's a way to synchronize receivers by measuring the delay of the network and compensating for that. And either of these are useful for things like video walls or synchronized displays. Okay, jump into a little bit more detail on the codec. So most of the initial implementations of IPMX use this JPEG XS codec, which is the latest flavor of JPEG. It gives you visually lossless at 10:1 compression ratio. That means that an expert looking at it can't see the difference. You get very near visually lossless at 14:1. That's kind of a magic number. It gets you to that 850 meg, just under the 1 gig limit of 1 gig Ethernet. And very few people can see the differences even at the 14:1. Ultra low latency and very small footprint. You can do it in FPGAs, you can do it in CPUs, GPUs, etc. I'll talk a little bit about the logo program. There's a presentation coming up later with more details, but again, the idea is if an end user picks up an IPMX product, it's going to have a logo on it, and it's going to say IPMX with something underneath it, and things like uncompressed or JPEG XS or H.264, so it's just super obvious that they know they get that plug-and-play experience. And we have testing programs. We just did a testing event last week, actually, where we had about 16, 17 people from a multitude of different vendors doing interrupt tests, and everything worked great. So things are really moving along quite well. This plan will be rolled out later in the year. And the idea behind this is that we come to this like just works. IPMX just works. It's not a headache to the system integrator. It's not a headache for the customer and end user. You don't have to worry about the compatibility issues. NMOS is part of the control system. We talked about it, but if you missed the presentations yesterday, just a very high level overview, what is NMOS? It's this open specification that allows you to make connections between senders and receivers. And there's a couple ways to do it. You can use it with traditional button panels. Most of the control vendors here support NMOS. You can hit your destination source take, or there's systems that do it GUI based. There's a nice Matrox system here called Conduct IP. That's a very good way to build up simple NMOS systems that can extend as needed. But it really, at the end of the day, what does NMOS do? It brings the plug-and-play, push-button simplicity to the AV over IP routing. So how does NMOS work? Just at a high level, in this case, you've got a couple endpoints. You've got, let's say, 2 sources that would be cameras and a receiver. As soon as the system powers up, all those endpoints talk to the registry, which is just a database running on a PC server somewhere, and it says, hey, I'm here. I'm camera 1, I'm from this vendor, I have this capability, on this display. And then the control system or the control panel can go query that registry and say, oh, okay, I see I have two cameras. I have a monitor here, a display, and it can even fill those in, whether it's a GUI or LED bit control panel. The user goes and presses the buttons, destination, source, take, and then it sends a command to the destination and says, send a subscription message to the switch. The cloud in the middle is your normal IT switch. And it says, subscribe to that stream using a technology called IGMP. And it says, disconnect from the first camera and connect to the second camera. So that's kind of the basics of how NMOS does this connection for you in a very simple way. So how does it extend for IPMX? We had to build in some extra capabilities. Again, in 2110, it's usually have a house standard format. It's 1080p 60, whatever it is. You know that you're just going to be sending a single direction signal path. So in this case, you've got a source, a PC running through a gateway. It's converting your video into IP through a switch, into another gateway, back to a display. That works great in 2110. Well, in IPMX, the PC can be multiple resolutions. The monitor can be multiple resolutions. How do you deal with that? Well, in the Pro AV space, they have this thing called EDID, Extended Display Identifier, and that's the way the monitor tells the sender what resolutions it can support. Well, notice there's not a direct connection between the monitor and the sender anymore. The green line kind of stops. So initially, all you could do is the green line would tell that receive gateway what its capabilities are, and this gateway would tell the sender what his sender gateway capabilities are. But what happens if you route to a few different displays and they all have different capabilities? Well, we built something called IS11 that handles that. So what IS11 does is these endpoints, they send their capabilities to the control system. So the transmitter says, well, I can do these resolutions and these codecs and this encryption. The receiver sends that. And the controller finds the least common denominator between these. Like, oh, okay, I see if you could send 2160p at JPEG XS with HTCP, this will work. So he sends an activation to the sender, and what he does is he takes away his current EDID and replaces it with a new EDID that tells the sender, here's what you're going to have to send to make this compatible. So it's all just an effort to make it more plug and play and easy and allow you to route something to multiple different displays and account for that. Okay, so in summary, the Pro AV market's looking for a better solution for Pro AV over IP. So we've come up with this interoperable solution that meets their needs. It's industry standard. It gives you beautiful quality 4K P60 over 1 gig. Has options for security, both HTTP and custom security, leverages all the other standards. This isn't something new that we just made up out of thin air. We're building on top of all the SMPTE standards, the ISO standards, the AES standards with compatibility through those, tested interoperability through JTNM, and it's an open standard, so not tied to one vendor. It'll be there forever. You don't have to worry about it ever disappearing. We're seeing it's gaining a lot of traction, certainly in Pro AV, but we're also pleasantly surprised places like medical, military, government, finance. It's really taking off and doing a great job. If you want to see IPMX in action, you can see some across the street. We also have across the hall here. We also have some in our booth as well, South Lower 8707. We've got a bunch of different devices, and we can show you. And if you want some more detail on how all this works, please come by and see us and say hi. That's it. Any questions? Yes, sir.
Is anybody developing interfaces to take something like NDI and bring it into your network?
Yes. So how do we build gateways and bridges from existing technologies like NDI or other proprietary systems? So yes, absolutely. That's a big part of this is we have to bridge other technologies. NDI is not going to go away. It's there forever. And it's not trying to replace NDI, but yes, there are companies building bridges.
It's already an NDI camera on site that you need to take advantage.
Exactly, and that's exactly how it works. Is you would build gateways to get it into this ecosystem. So the idea is that the IPMX is the ecosystem that transports media around your facility. If you have anything that's something different, you just translate it on the way in. Yep, great question. Okay, anybody else? Yes, sir. Oh,
Is this technology free to the end user? So in other words, if I design a studio with the MPX, do I have to pay a fee, or is it already paid by the people who put it into their equipment, or how does that happen?
Yeah, the base IPMX, this Tier 10 standard, is an open standard. You can download it from the VidTrans website. You can, the VSF website. You can implement. There are no technology licensing fees to use the base IPMX. If you choose to use a compressed version of IPMX, like JPEG XS, there are some royalties required to implement that. And there's vendors that can provide some solutions for you. But if you buy an end product, if you're an end user, then, that's just something that is worked out between you and the vendor. So sometimes there'll be an option like, oh, I want to turn on the JPEG XS compression. Maybe they charge you a little bit more for that feature, but the base system is open and it is freely available.
I think your slide said 4K 60 at 1 gigabit per second. What kind of glass-to-glass latency can you get with that?
That's about 32 lines, glass to glass.
32 lines.
Yeah,
okay.
Very low latency. It's intended for live applications,
yeah,
rental staging, those sorts of things. So you don't see much delay. Great questions. Okay. Got 39 seconds left before they hard cut me off. Anybody have anything else? Okay. Oh, one more, Doug. Yes.
Can you talk a little bit about that IS-11 and why that's so important, and why simply say a source changes its STP file or STP object to the registry? Why wouldn't that be enough to allow for like a seamless change of a signal parameter?
Yeah. Okay. Good question. So what he's saying is, if the sender changes his resolution, he's required to change his STP file. It's called a session description protocol file, and that goes to the controller, and then the controller is the only one that knows that happens. So to answer your question, the receiver doesn't know that he changed. In the 2110 world, you would have to go into the controller and reconnect that sender to that receiver. And we don't want to have that burden on the Pro AV user. We want the receiver to be smart enough to say, oh, I see, I get these RTCP messages every frame. Oh, I see you've just changed 1080 to 720. Let me automatically adapt to that without the user having to hit a button. Great. Okay, well, it looks like I'm out of time. If you have any more questions, come find me afterwards. Thanks so much for coming, and have a great show.